This keynote is proudly sponsored by Canada Life. Canada Life is a leading insurance, wealth management, and benefits provider focused on improving the financial, physical, and mental well-being of Canadians. For more than 170 years, individuals, families, and business owners across Canada have trusted Canada Life to provide sound guidance and deliver on the promises they've made. Canada Life, formerly Great West Life, is a partner in the Engineers Canada Affinity Program, dedicated to helping engineers, geoscientists, and their families create successful financial futures.
Welcome to today's keynote session of the 2022 Engineering Professional Development Seminars, sponsored by Canada Life. On behalf of Engineers Geoscientists Manitoba, I am P.Eng, a member of the Engineering Task Group, and I will be the moderator for today's keynote. Throughout today's presentation, we encourage you to send in any question you may have for the presenter via the chat. Please note this presentation is being recorded and will be available through the Engineering Hub for tomorrow until January. It is now my great pleasure to welcome our presenter for this keynote session on fighting Alzheimer's with an engineering approach, Dr. Zahra Moussavi. Dr. Moussavi, you can now share your screen.
Hello, everyone. It's hard to speak while I see no one. No face. I'm not used to it. I mean, I'm used to speaking.
I'll be on for you.
Yeah, thank you. At least see your face. Before I start, I would like to dedicate this talk to the young and brave students in Iran at the moment who are risking their lives and fighting for the basic rights of the living with the slogan of woman, life, freedom. I fully heartedly support all of them, despite the fact that they are being brutally suppressed. Okay, the talk today is about the approaches to diagnose Alzheimer's in particular, dementia in general, and the different approaches that we can follow, basically non-pharmaceutical approaches in order to treat dementia patients, particularly Alzheimer patients. Alzheimer's condition, in my opinion, is like a thief. It is a very clever thief because it comes and steals the most precious memories that one identifies himself or herself with. It is clever because people who are affected, they don't even know what they have lost. They just feel lost in time and space. Before we talk about diagnosis and treatment, perhaps we should talk a little bit about what happens in the brain of an Alzheimer patient. This picture that you see on the left, it is a healthy brain. On the right, it is an advanced stage Alzheimer's. It is an MRI reconstructed scan. Of course, I must say that this is at a very, very advanced stage on the right side. At earlier stages, MRI doesn't have any classification power. There are tons of papers that claim that, yes, they can classify people with Alzheimer's from the healthy people. But the truth is that, no, at the early stages of Alzheimer's, at the onset, the older brain, at the age of equivalent to an Alzheimer patients, let's say 60, 70, the older brain looks like the brain of Alzheimer patients. At early stage, imaging does not have any classification power. At advanced stage, well, everybody knows that they have some sort of dementia problems. But what we know about the effect of dementia or Alzheimer's in the brain is that the cortex shrivels up, damages the areas that are involved in planning, remembering, particularly prefrontal cortex. And this shrinkage is especially severe in hippocampus, which is an organ deep in the brain. A hippocampus is right behind our nose, about let's say 2 centimeters deep this direction, and 5 centimeters deep down from the surface of the skull. We cannot access that easily by the surface stimulation because it is in deeper area. Hippocampus is responsible for forming long-term memories, and that is the one that is especially affected by Alzheimer's, and that's why the people have they don't have a good short-term memory. It means that nothing can be formed into long-term, but all long-term memories are usually intact, at least at earlier stages. And the other thing that you see is that the ventricles in the brain enlarges and fluid fills them up too. This slide shows you how the proteins, beta amyloid and tau proteins affect the neurons. In simple words, what they do is that they surround a healthy neuron and disconnect that neuron from the other neurons. They destroy synapses too, especially the tau protein that creates tangles. They make up some twisted strands of tau protein that destroy the synaptic connection between the neurons. For us engineers, the way that we can understand it very well is that these synapses are communication channels between the neurons. In a healthy brain, these synapses, these communication channels are intact, and these neurons can communicate with each other so that we can do cognitive tasks. When the tau protein comes and creates tangles, as if in this slide, these synapses are being broken, and therefore a neuron loses the connection with the other neuron. How we can diagnose Alzheimer's condition? Well, there are clinical assessments, which include neurological assessment by a neurologist or a neuropsychiatrist, and they use often a standard questionnaire and interview the patient and the caregiver. Diagnostic aids, imaging, everybody knows about that. MRI, PET is better than MRI because it can also identify, for if in case of Lewy body dementia, or PET can identify the beta amyloid and tau better if there are. And but as I said, at earlier stages, at the onset, at the very, very early imaging, it does not have that much classification power. There is a technique called TMS, transcranial magnetic stimulation, paired with pulse and latency in evoked potentials. The group in Italy are quite famous that they use this, and it seems their accuracy is pretty high. There are EEG analysis, but in general, EEG is a very gross representation of brain activity, and its classification power is also very low at the earlier stages. In my team, I use these two last ones that are underlying: egocentric spatial orientation, I briefly explain it, and electrovestibulography. But before I explain those, just touch on treatments. There are medication. The most famous one, Aricept or donepezil, which is being sold millions of them every day. Perhaps it would be interesting for you to know that the efficacy of all these medications are low. In Aricept's efficacy is about 1 in 42 to have a drastic effect, and to be used as a stabilizer, the efficacy compared to sham has been reported to be about 30%. There are other types of medication too. Some of them might be familiar for you. The newest one approved for Alzheimer's is aducanumab. I leave it up to you to Google and to see what is the efficacy of this promised medication. There has been 2 studies that says that there is actually no benefit. But some people show, it is possible that some people show drastic effect. I'm not claiming that the efficacy of non-pharmaceutical treatment is way better, but at least it should be investigated much more, in my opinion. There are a number of non-pharmaceutical treatment, TDCS, TACS therapy. I talk about that a little bit more. There is a light stimulation. I personally do not believe it because the penetration is so low, and besides, we don't have photoreceptors over our cognitive area of our brain. So it is my personal opinion that I don't believe in light stimulation. However, there is a transcranial electromagnetic stimulation. I saw a good paper on that. It is as if you connect 8 cell phones like radars around the head. It is non-invasive. The patient doesn't feel anything. And the paper was interesting to me because it seemed that it affects to the amount of the tau protein. It reduces the tau protein. However, they did not see any clinical improvement of the patients. There is hyperbaric oxygen therapy, which is being applied to people with concussion. I have seen small studies that claiming that they want to apply it to Alzheimer patients too, with some, but the studies have been very small in number. There is a lady in close to us in Fargo who does apply it to concussion. I haven't seen her to apply it to dementia Alzheimer patient though. There is a RTMS, repetitive transcranial magnetic stimulation. I have used it. I was the first one in Canada who used this treatment, and 4 in the world. And we just are about to finish our large clinical trial on that. Well, I can talk a bit more about this one too. There are cognitive exercises paired with transcranial alternative current stimulation or TACS. I will talk more about this one too. So medication, as I said, they are not very effective. At best, there are 2.5% for drastic effect and 30% for very stabilizing effect. And even that may fade away after a few months. So non-pharmaceutical treatment, I will talk about RTMS, TACS, TDCS, daily cognitive exercises. And these are, as I said, there are the rest of treatments that are being researched in a small sample sizes. In Manitoba, this is what we do in our lab. I'm dreaming of having a center to dedicate to this personalized, optimized treatment for patients. We do, in our limited capacity, what we do for every new patient who come to our labs, we run a few diagnostic tests. They all have send me the diagnostic reports from their neurologists, and then we run our own diagnostic tools like a spatial test, EVSG test, and we have imaging report, physician's report. Then, based on the result of these, we decide on which study, which treatment to enroll the patient for, which treatment they are eligible for. And my goal is to personalize treatment as much as possible to the patient problem. We receive patients with different diagnoses. The majority have Alzheimer's or Alzheimer's mixed with vasculature symptomology, but there are some who have Lewy body dementia or vascular dementia. I exclude Parkinsonian people because it takes time if I want to explain why I exclude those ones. But frontotemporal dementia we accept as well. But the majority of our patients have been Alzheimer's or Alzheimer's mixed with vascular. Then the treatments that we have is RTMS, TACS, and cognitive exercises alone. These two, RTMS, TACS, have can have different protocols too. And we offer these treatment every 4 months because no medication is also a cure. And also people use medication every single day. So no non-pharmaceutical treatment can also make a miracle. They have to be repeated over time. So we do monitor them again with imaging, with physician's report, with our assessments, and try to update or sometimes change even the protocol of the study that the patient is being enrolled to. And as I said, my dream is to have this one in a much larger scale. I have the result of 29 patients published, but we have had more than 200 patients in our studies. Some of them are still ongoing. One of our diagnostic tests, I was talking about a spatial orientation test. It is a virtual reality assessment. I run it in my office. Actually, I did run it on an immersive mode a few years ago on older adults, some of them healthy, some of them mild cognitive impairment. But nowadays I run it only in my office on laptop screen, and it is a cubic house. It has no landmark, no queue. One of these windows is randomly marked with this X, and then we rotate the house and we ask where that target window is. And the participant is supposed to tell me whether that marker is on the left side of the building, right side of the building, or back of the building. Front is obvious, so I don't ask that one. So it has 2 stages. Basically, this first stage is localization. It has a second stage too, which is going inside the house and finding that room with that X. When they go inside the room, they don't see any marker, any landmark, and everything from everywhere looks the same. So the participant has to use their internal GPS to find out where they should go, how to find that room based on what they saw from outside the building. I do not run the second stage on Alzheimer patients because they cannot do it. Absolutely, they get lost inside the building. And that, to me, is a very good raising flag that this person is on the path toward Alzheimer's or a major neurodegenerative dementia. I'm going to show you the result of this test on 300 older adults. Look at this graph. This is showing the error of finding the room inside the house. These people from 20 to 89 were all healthy. The last column, 80, they received 100% error. As I said, Alzheimer patients, even mild cognitively impaired patients, they cannot find the target room when they go inside the house. They get totally lost. But I want you to pay attention that how much the error increases by age, almost linearly or close to linear. It's exponential function, but almost linearly in this stage. People, internal GPS goes bad as they age. However, there is a significant difference between healthy brain and age-matched Alzheimer brain. So that test is quite good to raise a flag. I'm not saying that that test can identify vascular from Alzheimer's, but it can identify major neurodegenerative dementia at the very, very earliest stage, at the onset, before even clinical symptoms become apparent. That's my claim. The second stage, the localization, when I ran it on mild cognitive impairment and Alzheimer patient, this is the result, which shows quite a significant difference. Quite a significant difference between people who were MCI and Alzheimer's. This plot is showing the accuracy in localizing, which means just to tell me The target is on the left side of the building, right side of the building, or back of the building. The question is as simple as that. However, Alzheimer patients have a lot of difficulty even at that stage. So this is one of our, I would say, my diagnostic tests. So its credit is low. It is as much as I have credit. It's not, of course, not an accepted clinical routine, and it won't be in my lifetime either. There is another assessment that we have been doing it for the last 12 years. It is called electrovestibulography. It is assessing the vestibular response to physical stimulus. Vestibular response is in our inner ear. It is the organ that tells us where we are in a space. And it is one of the primitive organs that we have. We share it with mammalian for millions of years during the evolution. And vestibular response system therefore has a role in all neurodegenerative dementia, neurodegenerative conditions, not only dementia. It has a role in Parkinson, Huntington disease, and others too. Excuse me. And also, it is sensitive to mood and depression and anxiety. As I said, this is our vestibular system, these semicircular canals, and we put two very, very small, tiny electrodes, cotton balls electrode in the external ear, and we connect it to our differential amplifier filters, and we record the vestibular response. And then we run a relatively sophisticated wavelet near algorithm to detect the field potential. We analyze this field potential, and it seems that it has a very good classification power for diagnosis, to separate mixed Alzheimer's from the Alzheimer's and from the control. The accuracy was about 89%, which is quite high, actually. We use it as a monitoring for the treatment's effect. We also have been using it for predicting the response of a patient to an RTMS treatment at baseline. And it is extremely important and novel. I emphasize on that because RTMS treatment is not an easy treatment. Some patients find it a nuisance. It is poking to the head a lot, and it can be not necessarily painful, but it is not pleasant, and it requires the patient to come every day for a period of 2 weeks or 4 weeks. So it is a demanding protocol. So if we can predict whether a patient is positively responsive to RTMS or not at baseline, we are helping to optimize the treatment management quite significantly. So far, our accuracy has been about 76%. The papers have been published. Some are available online. You can find it out. What is RTMS treatment? I repeated that word a few times. And that is, I'll show you in more slides what it is. This picture is me, of course, with one of our very good patients, participants. It is at Riverview Health Center. It's a $100,000 piece of equipment. These coils each are about $15,000. This neuro navigation system with this computer is another $100K. My device is pretty old. It may become non-functional any day. Hopefully we can find some funding to replace it. Anyway, RTMS machine, electronically, it is pretty simple actually. It is a huge capacitors. It creates an electromagnetic field through this coil that when we hold it over the scalp, this electromagnetic field induces a current inside the brain. The coil is winding, the coil that we use is winding like a figure 8. Based on this winding of the coil, the maximum I'm not sure if you can see it well on the screen or not, but the maximum intensity of the pulse is at the center. This coil induces a current directly inside the brain. We give the RTMS the intensity of these pulses would be at the resting motor threshold, which we will identify that by first placing the coil over the motor cortex. For example, if I put it over the left motor cortex, I give pulses at about 50%, then increase it to 60% if I don't see it. And I look for an involuntary twitch in the finger. I locate it over the area that I know it is stimulating the finger. And as soon as I see a finger twitch, involuntary, I try to find out the minimum resting motor threshold. And then we carry on the treatment at that minimum resting motor threshold to the area that we want to give the treatment. So by doing so, by giving these pulses, we are exciting the neuron directly. It depolarizes or hyperpolarizes the neuron directly. Depends on the frequency. If we give it at very low frequency, it causes inhibition, which means that the neurons not only they don't become excited, but they become inhibitory. They use that usually for depression treatment. If we give it at high frequency, on the other hand, we are exciting the neurons directly. You can guess that in Alzheimer's treatment, we go with high frequency. So the main parameters of RTMS treatment is the frequency of the pulse. We go with excitatory high frequency. Is there a difference between 10 to 20 and 20 hertz? Not really. We give at 20 hertz, but it doesn't seem to be any difference between 10 or 20. The other parameter is the number of pulses. We give 1500 hertz pulses in one session. In the past, I have given 4000 pulses, and I didn't see any benefit of 4000 compared to 1500. So I go with the lower end. Treatment dose, it could be 2, 3, 4, 6, 12 weeks. Researchers around the world have used different ways. I have investigated for 2 and 4 weeks. The target area, the majority of the research have been done over dorsolateral prefrontal cortex, these two areas of the prefrontal. Why? Well, in a simple words, our prefrontal cortex identifies who we are. It is our executive brain. It is the area that is like a hub station. It has projection to almost everywhere else in the brain. So when you are stimulating here, we are hoping that we increase plasticity in the brain and affecting other areas of the brain too. Also for depression studies, almost everybody applied it to prefrontal cortex. And we hope that we improve the cerebral blood flow and glucose metabolism there too. And by the way, also, we know that Alzheimer patients, dementia patients in general, their executive cognitive functioning have been damaged, means that prefrontal cortex have been affected. However, it seems that other areas of the brain, like precuneus area, which is in the back, in the center, and that is directly for episodic memory, that is also affected. Recently, I personally applied to the precuneus and Broca area, which is responsible for understanding the structure of the sentences. I applied to these two areas recently for some patients. My good neurologist, neuroscientist colleagues in Italy, they have shown that when they apply it to precuneus, the result is quite effective. The large RTMS treatment study that I did, I ran it. It was a multi-center international. It is almost toward the end. We do not enroll any more patients in that protocol. I enroll in other protocols as well, but Montreal, which was McGill University, and Monash University in Australia, were the other two sites of our study. They have completely stopped enrollment. I only enroll on some patients for some protocols. This study has been randomized, double-blind, placebo-controlled. Some people received sham, some people received active. And we had 2 doses of treatment, 2 weeks versus 4 weeks, randomly assigned. And the assessment was the standard questionnaire, a lot of assessment. In Manitoba, I ran our own assessments as well, like a spatial test and electrovestibulometry. And we followed up with these patients up to 6 months, which is quite important in order to identify if rTMS is effective, how long the effect lasts, if it is effective. I'm not going to spoil the results today. Although the study has been finished, we have done the interim analysis, not the entire analysis, but I'm preparing the paper. I shouldn't spoil the result. All I can say is that, well, we have had a lot of placebo effect, especially in Manitoba. In my group, for obvious reason, my team treat patients very well. Patients become part of our family, and therefore our placebo effect have been the highest among the 3 sites of the study. There is yet another study that I offer, and many other people around the world have done that too, and that is transcranial alternative or alternating, here's a typo, current stimulation, TACS or TACS. That's a simple device, simple electronic device, and relatively cheap. It's about $11,000 US. And you can put those 2 electrodes in different protocols, anodal, cathodal, but when it is AC, it doesn't matter really which one is anodal, cathodal. We apply that AC, not DC. The device can give both DC, AC, and random noise. Application area usually again is the dorsolateral prefrontal cortex or temporal lobe. I don't give it to temporal lobe. That can cause perhaps hallucination too, if the current is high enough. But we apply to dorsolateral prefrontal cortex again. Frequency, I chose 40 hertz. Many people chose 40. After that, I wasn't the first one. I chose 40 hertz after Dr. Paul Fitzgerald in Australia. And 40 hertz, a little bit intuitively. Why? Because when we pay attention and we try to learn something, if you are awake and you are listening to my talk right now, you are generating 40 hertz band brain waves. For that reason, intuitively, it made sense to me that, okay, let's give the signal at 40 hertz. It's important to note that this current, it is first of all not the voltage, current that we give. Penetration is again very low. Maximum we expect to reach no cortex, but the amount of current is about just 1.5 milliamp peak to peak. 1.5 milliamp, how much of it goes inside the brain? Very little. And if you know, every time that the neuron is being excited, our neuron give an action potential of 120 millivolt. What 1.5 millivolt is going to do? Nothing really for the excitement. So it does not excite any neuron. All it does is that it boosts the excitability, perhaps. For the participants, I use this analogy that when you are boiling rice, you sometimes stir the pot so that every grain receives the same amount of heat. This is what it does, TACS. In my opinion, alone, probably it is not doing much. Although there are research that say that even if you give TACS alone, without anything else, people have shown improvement. I'm not too sure. I give TACS along with cognitive exercises. There are two mechanisms claimed for effect of TACS. We don't have much time to go through it. I skip it. Let me talk a little bit about cognitive exercise, and then I get back. I show you some results of TACS paired with cognitive exercise. I'm running at the moment another large clinical trial, enrolling into it for this study. Some people say use it or lose it. For the muscle, everybody agrees. If you don't exercise your muscle, you're going to lose your muscles. Everybody knows that. But whether this applies to the brain or not, is it fiction or fact? Well, when I started this study, cognitive exercise, exactly in that year, 2018, when I was running this study, there was a paper published by Bobby, this fellow. He's in Western Ontario, that said that this is a fiction. Cognitive exercise doesn't have any benefit, neither for older adults, nor for Alzheimer's, nor for dementia, and so on. So that was quite amusing because I like to put that title on my paper, but for professional papers, I had to change it and put a more descriptive. Otherwise, I really wanted to say fiction or fact. Okay. In my team, we developed an app. Initially, I had developed it in 2018. Of course, I didn't write the program. I just conceptually developed the games. It is 7 serious games. They call it serious games because it is for the purpose of neurorehabilitation. And I personally love this hexagonal room the best. I will tell you why. It has one game that I would say is unique compared to other games. We call it associative memory. It has so many different levels. It starts from one animal, one shape. Associative memory is one of the memories that we tend to lose as we age, get older, and in dementia, Alzheimer patients, it is almost non-existent actually. They cannot make any new association, and we try to enhance that associative memory by this one. We try to train them to associate two things that are irrelevant, and whether they learn it or not. So it is quite an important game to be practiced on a daily basis. And this is that spatial game, hexagonal room. Many older adults with mild cognitive impairment, they hate this one because it is quite challenging. With this game that it rotates and I remove the landmarks and so on, every time they have to find a target tile. With this game, I'm trying to make people to work to more on their internal GPS, basically to enhance their egocentric spatial orientation, internal GPS. The reason why I like it, and I believe that it is very important, has to be practiced on a daily basis, because I have shown you the result that on 300 people, mostly older adults, I have seen that their internal GPS, it gets deteriorated as they age, and we have to work on it and use less of use of these GPS for driving, basically, on a daily basis. Okay, so initially I started to run a study to use only cognitive exercise, and then later I paired TACS with it. So I'm going to show you the result of with or without TACS. And I call this app as Mind Triggers app. It is available on iPads and on Google Play for Android very soon as Google approves. And I have a good news. At the moment, it is $10 if you want to buy it, but very soon, Blue Cross is going to donate something. So I said, if you donate, I will remove the fee, and it will be free for all Manitoban and around the world. And I will put logo of whoever who donates to my research on app. And it seems that they are going to. Okay. It has received some attentions. I've received some calls for collaboration from Germany and US and Brazil. Anyway, the study was run. We had a primary outcome measure, which was an independent test because I was interested to check the far effect, not near effect. It doesn't matter to me that if people become better on the score of these games, they are practicing it every day, they should become better. No, that's not important for me. For me, is important whether these games have a far effect. Means that in a similar task, but independent task, they perform better. So my primary outcome measure was a standard WMS, which has sections of recall memory, delay memory, spatial memory, all of that. And we also assess them with another independent spatial cognitive assessment. Okay. These are the information about the two groups. As I said, I have tons of other people enrolled, but these are the published data that I'm going to show you. And half of them, 19 received paired with TACS, 10 received only brain exercises. The protocol was 4 weeks every day, but there is a big but here. I assigned a tutor to everyone. So they played with an instructor. So I assessed them baseline after the treatment and also after a month after the post-treatment. So after 2 months after as well to see how long the results can last. And I repeat this protocol every 4 months. I have had patients in our group who have been with us, the longest has been 9 years. I've had people who have been with us 9, 7, 4, 3 years. Soon I'm going to write a report on longitudinal results too. Here is one result of those 29 people, baseline, post-treatment after 4 weeks, follow-up after 1 month after the post. Between post and follow-up, there is a 4 weeks, 1 month period of nothing. As you can see, both groups improved significantly. The statistical test showed that the improvement is significant. The higher a score, the better. Between post and follow-up, interestingly, there was a slight improvement even though there was no treatment. In one group which received TACS, there was even further improvement. But at least they didn't decline. As I said, I assessed them after 3 months as well. And I don't have a graph for that, but I can tell you that Alzheimer patients do decline. The result doesn't last more than 2 months or 3 months. That's why that I repeated after 3 months after post-treatment, I repeat. So basically every 4 months, I repeat this treatment. This graph shows the difference between baseline and post, difference between baseline and follow-up. A little bit shows better. The group who received TACS, it seems that the result lasted longer and better. That's why that, and then I published, and as usual, the professional community told me that you didn't investigate sham TACS. I said, I know. So I have to study sham as well. Now I'm having people in 2 groups, sham TACS and cognitive, real TACS and cognitive. Why do I pair it with cognitive? Because I believe TACS alone may not benefit. And I feel that these people are on the slippery road downward. To be honest with you, I can't convince myself not to give the cognitive exercise treatment because I have seen its great benefit to people. That's just a personal, I can't go over that conscience just because of publication or convincing another research community. what I have seen is that more than 90% of this population improved significantly. The other 10%, they were advanced stage Alzheimer's. They neither improved nor declined. So it was beneficial in order not to decline, but they didn't, about 10%. They were advanced stage. So it is effective for early stage Alzheimer's. And simultaneously with cognitive exercise, as I said, it seems it enhances positive results. That's the paper that is available online on these 29 people. And the main conclusion is that non-pharmaceutical treatment seems to be more effective than medication, perhaps. Some people respond well to RTMS, some people don't. As I said, I'm not going to spoil the result, giving you the result of our RTMS treatment in details. However, I can tell this much, that some people do not respond to RTMS treatment. And I have a guess as why. We are investigating that. And that's why that I think the protocol of RTMS and the type of treatment that we are giving is quite crucial and has to be determined or guessed at the baseline. Almost everyone responds to brain exercises, and especially when it is paired with TACS. So I would say use it or lose it. It is a fact. But the key also is to keep these exercises dynamic, and also the key in my study was that they had an instructor. We don't give the exercises to the patient and say that, okay, go home and exercise. They don't. Even if they're caregiver to make them to do it, it is not the same as having a tutor. The same analogy applies. You can exercise in your basement for your muscles, or you can go to the gym, or you can hire a personal trainer. Which one gives you the best result? I leave it up to you. I should acknowledge NSERC, CIH, no, not CIH, CIHR supported my other sleep studies. CRC, Canada Researcher Grant, Riverview Health Center, Western Brain Institute, and most importantly, people's donation for all of this. And last but not the least, this is my mother who had Alzheimer's and was my motivation to start the whole research. And this lovely lady, Beth, was our very, very first patient with RTMS, who was always telling me that she was only 20 years old. That's why on her birthday, we had a cake 21 years old for her. And a good researcher is always as good as her or his fellows. I have been lucky to have brilliant students, volunteers, and so on. This picture shows only a number of them in the summer of 2018. Thank you. I will be happy to have any question that you may have.
Perfect. Thank you so much, Dr. Moussavi, for sharing your findings of your research. It is really interesting to see what can be done to improve the health of Alzheimer's patients. And I'm very, very glad to hear the positive result that you got. So for our audience, so if you have any questions you'd like to ask Dr. Moussavi, please type them in the chat and I can read it out loud to her. So we have our first question here for you, Dr. Moussavi. So do you think RTMS could prevent the onset of Alzheimer's? Probably not if it is low frequency, is it correct?
First of all, low frequency causes inhibition. No, we don't want to give low frequency. We want to excite them, because what Alzheimer's does, as I said in one of the slides, those tau and beta amyloid protein come and destroy synapses and doesn't let the neuron to be excited. The neuron is a little bit lost there before it dies. And once a neuron is not excited, our brain is so efficient, say that, why should I feed you? Go die. So neurons die in isolation. That's why that we need to excite neuron. Excitement of the neuron Can be done by RTMS, yes, but can also be done by cognitive exercise, by anything that you learn. If you talk to a friend, you are exciting your neurons. If you go outside, you're exciting your neurons. If you learn a new task, if you do anything, you are exciting your neurons by anything. It is like a firework in our brain. The more excitement you give to your neuron, the more in a regular pattern you make the neuron to be activated, the better results. That's why the cognitive exercise is so important. But back to your question, can RTMS avoid Alzheimer's? I don't know. The simple answer is, I don't know. We don't even know if it can combat Alzheimer's.
Yes, thank you for your answer. And I think that, maybe more research in the future would definitely help out to find out if it works or not. So I think Cliff has a question for you. So there's, to build up for that, so David Smith found that vitamin B and omega-3 were effective to assist in reversing cognitive decline, but that B3s are effective with a raise of DHA and omega-3 are only effective with a raise of vitamin Bs. So do you suppose that the combination of these vitamins and essentially fatty acids would work together with RTMS treatment?
I would say get all the vitamins that you think you can have. Get all the good diet that you think it is beneficial. Do it all. It may help. Those reports are not BS, as it is in the comment. But the point is, this condition, dementia, is extremely heterogeneous. Even if, first of all, we do not know that subtype diagnosis with 100% accuracy until somebody dies and we can do autopsy of the brain. That's number one fact. Number two, as I said, it is extremely heterogeneous. Even if you are you're almost sure that a person has Alzheimer's, people with Alzheimer's have their atrophy of the brains in different areas are different. People are extremely different, heterogeneous population. So omega-3 fatty acid, or there was a very famous TED talk on coconut oil that was so effective on the husband of that lady. She's right. She saw miraculous effect on her husband. Good for her. It doesn't have that effect on many others. These are very, very small studies. Mediterranean diet has been shown to be one of the best. I tell you a lot more about nutrition because out of curiosity, I have studied a little bit. I'm not claiming that I'm an expert in it at all. It seems that I put my feet in different people's shoes a lot. I don't want to do that. I'm not a physician either, not a nutritionist, but I read a lot. For example, turmeric in animal studies have shown that it can reverse Alzheimer's. First of all, mice Alzheimer's is a lot different than humans Alzheimer's. Number one, there are 52 different types of mice model for the Alzheimer's. Second of all, the amount of turmeric to reverse Alzheimer's in the mice, if you translate it to that amount for a human, you are going to damage your liver, for sure. So turmeric, even in Indian food that they use a lot of turmeric, it is not equivalent to amount that is going to reverse Alzheimer's. The same with cinnamon. Cinnamon in mice model has been found to reverse Alzheimer's. But for human, if you have cinnamon too much, you're going to have toxic effect. So read these nutritional studies with a grain of salt and pepper, and it's good to have a good diet, but whether they can avoid Alzheimer's, I doubt it. Whether they can help with the brain health, I think so. I follow them myself. Yes, but again, I gave a TED talk on how to avoid Alzheimer's. I would say stress is number one. Try to avoid the stress. We cannot avoid it, but we have to control it. So try all different meditation, breathing, anything that can help you to cope with the stress. Sugar is bad for the brain, we know that. But if eating ice cream helps you to reduce your stress, for sure, go for it. Do it. Because the effect of stress on killing the neurons is much more than the effect of that sugar or ice cream.
Yeah, that sounds wonderful. Thank you for your answer.
My husband would be happy to hear that. All
Yeah, I mean, I really enjoy ice cream, so I'm probably gonna go and get some today. Another question I have with me is that your description shows broken links in the neurons. So does the exercise repair the links or build the new ones? What caused this improvement?
It doesn't, I don't think it does repair the link. But you know how many neurons that we have? We have about 80 to 100 billions of neurons. The number of synapses, those communication, 2 to the power of that 80 billion neurons, which is true. I don't even know how many. It is astronomically large number of synapses we have. Each neuron is connected to other neurons through these synapses, and there are many, many, many redundancy. So if we lose 1 million of these synapses, we shouldn't worry too much as long as we can strengthen the other existing synapses. That's the goal of plasticity. That's the goal of TACS, TACS, TMS, cognitive exercise. That first of all, we should strengthen the strengths of the synapses that are existing and are connecting to a neuron. By strengthening means that the more you use it, it is like the more you walk through the same path and like hiking a trail, the more you walk over that path, the more the softer, the smoother it becomes. That's the effect of that. And furthermore, the new sciences of the neuroscience shows that in the last 20 years, it shows that regeneration of the synapses is a reality even at old ages. When we start to learn something new, we have to build new synapses. Our neurons are forced to build new synapses. For example, let me give you just one example. Are you right-handed or left-handed? Assume that you are right-handed, okay? Since you are right-handed, it means that the motor cortex of your left brain is quite developed for your right fingers to control. Now, try to become left-handed. Start to do it. By doing that, the neurons of your right brain have to be activated and have to connect with different parts of your brain, like your speech, like your prefrontal cortex. So those synapses have to be activated in order to order this left hand to right. So you have to generate new synapses. Any new things generates new synapses. So if you don't know music, go start learning music. If you do not know dancing, go start learn a new dancing. Start doing something new. If you are used to Sudoku, go ahead, do it every day. Sudoku for me is a mechanism to cope with my stress and anxiety, believe it or not. But if you are used to it, it is just for strengthening. Don't forget that you should start new things every single day. Something new, anything.
Yeah, I think that's a wonderful recommendation. Start a new thing, take a small step by step, and then it'll become a regular thing. Yeah, I think that's all the questions we have for you today, Dr. Moussavi. I'd love to thank you again for joining us at Ingenium. So do you have any other comments before we wrap up this session?
Well, this is a passionate area that I am quite passionate about, and I can talk for hours, but I know everybody has a strict schedule. No, I would be happy to have to receive your feedback, your comments, your questions by email, and I'll do my best to answer.
Of course. Thank you again for your presentations. And thank you all for attending this keynote. Did you miss part of the session? Please don't forget to check out the Ingenium Hub's on-demand library for recordings of this and all of our live sessions, as well as exclusive professional development content. I'll see you in the next session.
Canada Life is committed to improving your financial well-being. From learning about your group savings plan options to creating short and long-term financial goals. From saving for a child's education to paying down student or other debt. From dealing with a difficult situation to going back to school or retiring. We're also committed to improving your physical and mental well-being. With quick and easy access to healthcare services, well-being resources to help you and your loved ones, and services, solutions, and educational tools to support you, including member guides and investment retirement specialists to show you the way. Through uneventful times, changing times, good times, and tough times, Canada Life is here for you. For life as you know it.
Thank you for watching. Visit the Ingenium On Demand library for more exclusive content.